Some materials are just substances. But every now and then, you find one that's a story of how empires were forged, how revolutions were built, and how our world, even today, stands on its shoulders. We're talking about iron and its incredible upgrade, steel. This isn't just a metal, it's the spine of our entire modern age.
And yet, every titan has an Achilles heel. For all of its strength, for all of its presence in pretty much everything we do, iron has a deep, fundamental flaw. So, that brings us to the big question. Is the king's reign really as secure as we think? Or are we starting to see some serious cracks in that iron crown? That's what we're here to figure out.
So here's how we're going to break it down. First, we'll go back to the very beginning, to the Age of Iron. Then we'll see how it was engineered into something totally new. We'll look at its absolute dominance today before we get real about the cracks in the crown. And then, of course, we'll deliver our final verdict.
Okay, so let's set the scene. We're going back to around 1200 BC. For thousands of years, bronze was king. But then, humanity finally figured out the secret hidden in the most common of rocks: how to smelt iron. And in doing that, they unleashed a force that would literally redraw the map of the world. This was more than a new material, it was the beginning of the age of mass metal.
Now, this journey was long and it was brilliant. It starts with these crude smelters, but then it evolves into the legendary wood steel coming out of India. You can see its mastery in things like the Iron Pillar of Delhi, which, by the way, has barely rusted in 1600 years. Then you see its power explode with the blast furnaces in medieval Europe. But the real game changer? That came in the 1850s with the Bessemer process. Suddenly, we could make high-quality steel on a scale nobody had ever dreamed of.
So why did iron win? What was the big secret? Well, it's actually pretty simple. It was a democracy of material. See, bronze depended on tin, which was rare and expensive. It was a metal for the rich, for the elites. But iron ore? Man, iron ore was everywhere. It was the people's metal. It was cheap, it was abundant, and pretty much anyone could get their hands on it. This didn't just create new tools, it completely rebalanced power itself.
But here's the thing. Pure iron was just the start. The real magic happened when we learned to play with its chemistry. Just by adding a tiny bit of carbon, we turned a pretty soft metal into the miracle we call steel. And this new ally was so perfectly tunable, it basically gave us the power to engineer a whole new world from the ground up.
So check out this number, over 2,000 megapascals. That's the kind of tensile strength we can get from advanced modern steels. Now, what does that actually mean? Well, to put it in perspective, it's like hanging 3 grand pianos from a steel bar no wider than your thumb. It's an absolutely incredible level of engineered strength.
But steel's genius isn't just about being strong. It's got this whole suite of superpowers. It can bend without breaking, you can weld it, you can shape it, you can tune its hardness for basically any job imaginable. It resists getting worn out from repeated stress, and this is a big one, its magnetic properties are what make every electric motor and generator on Earth actually work. It really is the ultimate all-rounder.
And all of that history, all of that engineering, brings us to right now, to today, where the reign of steel is, without a doubt, absolute. I'm not exaggerating when I say it is the material that holds our entire civilization together. If you don't believe me, just look at this. About 95%, 95 of all the metal produced by mass in the world is iron and steel. All the other metals you can think of, aluminum, copper, titanium, you name it, they all have to squeeze into that tiny little 5% slice. In terms of sheer scale, nothing else is even in the same league.
And you see that dominance everywhere. I mean, it's the rebar inside our concrete buildings, the massive beams in our skyscrapers, the hulls of our ships, the frames of our cars. From wind turbines generating our power to the washing machine in your laundry room, if you took away steel, the modern world would just stop.
And its reign is far from over. Global demand is projected to be nearly 1.8 billion tons a year. So no, this isn't some historical artifact we're talking about. It's a living, breathing, and absolutely massive part of our world that just keeps on growing.
But no king can rule forever without a challenge. And steel, for all its might, has 3 major undeniable flaws. And today, those flaws are seriously threatening its throne. So it's time we took a hard look at the cracks in the crown.
First up, the most famous one. We all know it. Rust. Plain old carbon steel, if you leave it out in the open with oxygen and water, will just basically dissolve.
It's why we have to spend billions and billions of dollars every year just to protect our bridges and ships and pipelines from falling apart.
Second, there's its weight. Steel is heavy. There's no getting around it. And in a world that is obsessed with efficiency, especially when you're talking about airplanes or electric cars, that heavy-duty nature is a serious disadvantage when you compare it to lighter stuff like aluminum or carbon fiber.
And finally, we have to talk about its environmental cost. Making steel the old-fashioned way is incredibly carbon-intensive. We're talking about releasing, on average, 2 tons of CO2 for every single ton of steel we make. In the world we live in today, that's a tough legacy to defend.
Okay, so we have all the evidence, a history that transformed the world, unbelievable engineering, total dominance today, but also some very real flaws. It's time to put it all on the scales and deliver our final verdict.
All right, let's look at the report card, and it tells a really clear story. Historical impact? A perfect 10 out of 10, no question. It built our world. Mechanical properties? Get a 9. It's tunable, tough, ductile, but it loses a point for that pesky rust problem. And then look across the board. Workability, scalability, cost, versatility, lasting relevance. It's getting elite scores, 9s and 9.5s. It's just in a class of its own.
So when you add all those scores up, there's really only one conclusion you can come to. Even with the rust, even with the weight, and even with the emissions, the combination of its history, its unbeatable performance for the price, and its sheer, mind-boggling scale puts iron and steel firmly in the S-tier. It is, without a doubt, the undisputed champion. And so it endures. Why? Because for the money, you just can't beat its performance, not at the scale our world needs. It's also infinitely recyclable, which puts it at the very heart of a circular economy. And it's not sitting still. Innovations in green steel are trying to solve that carbon problem. When it comes to the fundamental job of building a civilization, there is simply no equal.
So the heavyweight champion holds on to its crown. But in a world that craves lightness and efficiency, there's a challenger waiting in the wings. A metal that was born for the skies. A metal that doesn't rust. So can the lightweight contender, aluminum, ever really challenge the Iron Throne? Well, that's a question for next time.